So it's this problem, what volume in litres of a 2.50 molar NaCl solution would be needed to completely react with 225 grams of FeNO33 solution. And what we're looking at here is a two substance type problem. So we've got an A and a B substance. And what I'm saying here is that A is what we're starting with and B is what we want. So what volume of a 2.50 molar solution of NaCl. So NaCl becomes B, what we want, and the FeNO33 will be A, and that's what we're going to start with. Now since it's a two substance type problem, I'm going to use my modified flowchart. QA gives moles of A, gives moles of B, and that gives Q of B. So the Q's here are just quantities, so it doesn't really matter what we're starting with. Our first target is to find the moles of what we're starting with, then the moles of what we're looking for, and then the quantity of what we're looking for. Now if we're starting with 225 grams of FeNO33, so we're going to start off with 225 grams of A. And I know that my first target is to find moles of A, so I'll put grams of A on the bottom to cancel the grams of A and put moles of A on top because that's what I want. And the relationship here is that 1 mole of A is equal to the molecular weight, which is 241.88 grams of A. So that's our first step. Right now we're at this point moles of A. Now we need moles of B. So I know moles of A is going to have to cancel, so I'll put that on the bottom. I'll put moles of B on top because that's what I want. That relationship is going to be gained from looking at the reaction equation. Now B is the NaCl, and that says 3 moles of B. And the A is the FeNO33, and it looks like there's 1 mole of that. So the relationship here is 3 moles of B to 1 mole of A. So at the moment we're here in the equation. And what are we looking for? We're after litres. Now if I'm looking for litres, I know that I'm going to have to get rid of those moles, so I'll put moles of B on the bottom, and I'll put litres on top because that's what I'm looking for. And what I've got here is the relationship between the moles of B and the litres, which I can gain from looking at the molarity. Now here we've got the molarity is 2.50 moles of B per litre. It's 2.50 MB equals to that. It's equal to that. It's 2.50 moles of B per litre. So if I want to get to the volume, I guess what I'm doing is I'm using my equation here, molarity equals moles divided by volume in litres. And if I want volume in litres, then it would be moles divided by molarity. So I'm just manipulating that algebraically, which is the same as saying moles times 1 over molarity. Alright, so that's a justification for what I'm doing here. If I've got 2.50 moles of B per litre, then by multiplying by 1 litre over 2.50 moles of B, essentially what I'm doing is I'm taking the moles and multiplying it by 1 over the molarity. You see, this is the molarity, so 1 over the molarity is going to be 1 litre divided by 2.50 moles of B. The other justification here is what, like I said before, the cancelling. You know the moles of B have got to go. You need litres, so you put the moles of B on the bottom, you put litres on top, and then you look for the relationship, which is 2.50 moles of B for every 1 litre of solution. So the other thing I can tell you here is that if you've got the moles of B and you're multiplying it by 1 litre over 2.50 moles of B, you are multiplying it by 1 over the molarity. Now with the significant figures, we've got 3 sig figs here and 3 sig figs here, which gives us our answer in litres as being 3 sig figs as well.